Lesson 8.3, arc length. So in this lesson, we're going to define arc length. To do that, let's look at what a radian is. A radian is the length of an arc. So we'll talk about what an arc is in a moment on a circle when the radius is equal to 1 unit. Basically, a length of an arc is the distance on a circle given a central angle of rotation. So if this radius is 1, we call that, that's what a radian is. The circumference of a circle, if you remember right, is 2 pi times the radius. And that's for any circle, anywhere, any place in the whole wide world. So an arc length, then, is the distance traveled on the circle given that angle of rotation. So we want to make sure we have that angle of rotation in radians. And if we do, we are going to multiply it by the radius, that's the length from the center to the outside, and that's going to give us that arc length, that distance traveled. So the one thing I want to do here, you guys, is I want to just show you something. So what if we have a circle, and I'm going to show you a quarter rotation. Okay, so let's take a circle here. And so let's go like this. So we have a circle. Let's make this circle a little bit bigger and then make this even bigger. Okay, so if all of these have a quarter rotation, in other words, I start from here and go to here. Okay, so we know that's 90 degrees. But if I'm just kind of interested in this arc length, I want to show you something that's important. So these all have a quarter rotation. They're all 90 degrees rotations, or they're all pi over 2 rotations. Pi over 2, pi over 2. That's measured as a radian. Okay, with one unit, so 90 degrees or pi over 2 rotation. Well, what if the radius is this is instead of 1, it's 2, and this is 3? They're all a quarter rotation, but these arc lengths change. These distances change here. And here's why they change, is because if I'm trying to compute this distance, I take the radius multiplied by the radian measurement of this rotation. So 1 times pi over 2. So this base distance is pi over 2. 2 times pi over 2 is 2 pi over 2. Or pi, this is bigger than that one. This is half as big. And then this one is 3 times pi over 2, or 3 pi over 2. So you can see as this radius increases, this relationship increases, whereas the constant is this degree of rotation. So that's why it's important to start to understand arc length. So in a circle with a radius 6.5, an angle measure of 5.5 radians, find the length of the arc to the nearest tenth. So what I would do for this, you know me, I like to sketch a picture. So I'm going to sketch a picture. I'm going to put my radius here, 6.5. And then what I'm going to do here is I am going to think about having this rotation. All right, so this rotation from here to here of 5.5 radians, I need to find this arc length. Straight up use my formula here. So capital S stands for arc length equals 6.5. That's my radius multiplied by this in radians. 5.5 radians. Let's just compute this. 37.75. Round, where am I rounding? Round to the nearest tenth here. I'm sorry, that is not 30. My bad. It is 35.75. Round to the nearest tenth, 35.8. And does it give me any measurement? I don't think it does. So 35.8 units. Okay, let's try another one. The circle has a radius 9. Its angle measurement is pi over 6 radians. We're going to straight up use this formula. So S equals 9 multiplied by the rotation in radians, pi over 6. This is 9 pi over 6. Think about it this way. 9 times pi, 1 times 6, 9 pi over 6. I can simplify that a little bit. That's 3 pi over 2. There's a common multiple here and here. Final. it says in simplest form. Use this pi button when you do your delta math, okay? So that's the length around the circle when the radius is 9 with this as my rotation. In question 3 and 4, we're going to have to do a little bit different type of computation. We're going to use algebra here. So it says the angle measure is 4.9 radians, but now it tells us the arc length is 3.4. Remember that the arc length equals radius times rotation in radians. So theta is the rotation in radians. Don't confuse r with radians. R is the radius. So if I want to find the radius, then I am looking for you to find this value right here, which means they must be giving me the other values. So this is radians, this is arc length. Just make sure you put them in the right spot here. Arc length goes on this side. Radius times radians, 4.9 radians. Divide each side by 4.9. Let's simplify. Let's use our calculator here. 0.6938, round to the nearest tenth, 0.7. In a circle with radius 5 and an angle intercepts an arc of length 25 pi over 2. So that's arc length. That's going to go here. Radius is 5. 5 is going to go here times theta. So we're going to find the angle in radians in simplest form. Okay, that's all right. So we don't want to round here. So we'll put the 25 pi over 6 here equals 5 times theta. Divide both sides by 5. Or here's a better thing to think about. Instead of dividing both sides by 5, because this is my variable here. Pi is not a variable. Instead of dividing both sides by 5, I'm going to multiply both sides by 1/5. We talked about that earlier this year. So 5 pi times 1/5 is 5 pi, I'm sorry, not pi, 5 theta over 5, which is just theta. Those cancel out. So that's why I multiply each side by 1/5. And so this ends up being 25 pi over 30. You can simplify that a little bit here. That should be 5 pi over 6. Done deal. I have a couple more examples here. We're going to just change up a few things. Remember this, if you have the central angle in degrees, so let's say you have it in degrees, you need to convert it to radians. Remember, we convert it by multiplying by pi over 180. So we're going to have to do that before we use the arc length formula. So circle 0 shows below has a radius of 14 inches. To the nearest tenth of an inch, determine the length of an arc X, subtended by an angle of 1.7 radians. So the length of this arc X, well, in this case, I don't actually need to convert here because they give us in radians. So we'll use that in just a moment. But S equals radius times radians. Radius is 14. Radians here is 1.7. So let's simplify this. In this example here, we'll simplify it to 23.8. Nearest tenth of an inch. There we go, 23.8 inches. We didn't need to use this yet. We will use that right here. Okay, so here's an example. We have 38 degrees for our arc length. We have 91 degree rotation. So we do need to convert that rotation. So we'll do that in just a moment here. So S equals radius times the rotation in a radian. So arc length in this case is 38. This value is arc length equals what we don't know times this value as radian. So before I put that value in here, I'm going to convert. So I'm going to convert this 91 degrees times, so I'm going to multiply it by pi over 180 degrees. All right, so that is 91 pi over 180. That's the value I'm going to use right here. Okay, I do not need to put it in a decimal at all. I just want to throw that in there. And now to solve this problem, this is why it's important to use this, to invert this, to use the reciprocal. Because I could divide both sides by this value, 91 pi over 180, or I can multiply both sides by the reciprocal of it. So 180 over 91 pi. Because these are going to cancel everything on this side. So this side is what x is equal to. And over here, let's just simplify. So we have 38 over 1. We'll turn that into a fraction. And then what does it say? Nearest tenth of an inch. This is how I would compute that then. I would make sure that I found the product of 180 and 98. So 180 times 98 all over parentheses 91 pi. So it kind of looks like this. Just to show you what that looks like on your calculator, it looks something like this. 180 times 38. Oh, my apologies here. That is 38. My bad. And yeah, just type that in your calculator. Use the pi button. The pi button, if you don't remember, is second caret up. So it's the pi button here. That way we're not approximating. We're going to the nearest tenth, 23.925. Nearest tenth is 9. Look to the right. It's a 2. So 23.9. Final answer here. And nearest inch, tenth of an inch. There we go. One more for you here. Okay, so what are we trying to find? We're trying to find angle X here. We got the arc length. We got this radius. So that's not a bad deal. F equals R times this rotation in radians. Find to the nearest tenth of a degree. Ooh, we want to find it in degrees. So we're going to find it in radians first, and then we'll convert it to degrees. Okay, so here we go. We're going to put the 14 is going to go here. The radius, 8 is going to go here for R. Theta is right here. All right, so theta is my unknown. Divide both sides by 8. Theta is 14 over 8. And if you want to, you could put that as a decimal. 1 3/4. Let's see. It doesn't. So you got a couple options. Sorry about that. You can either write it as 1.75, or you can write it as 7/4. Either way, that's what theta is equal to. Now I need to. My next step here is I'm going to convert this thing. So I'm going to need to convert to degrees, because it wants it in a degree measurement, and this is in radians. Theta is always in radians. So to convert this, I go 7/4 or 1.75 radians times 180 degrees over pi radians. We talked about this conversion in our last unit. All right, so we're going to multiply. Let's just straight up. We know we're going to go to the nearest tenth of an inch here. So here's what it looks like on my calculator, 1.75. Again, you could use 7/4 if you'd like, times 180 divided by 1 times pi. So let's just write that as, or type that in as pi. Let's hit enter. There we go, 100.26. We're going to the nearest tenth of a degree. So 100.3 is my final here. Degrees. And there you go. So you have arc length.